So here is our division method for solving questions on data comparison or quantitative comparison in the GRE exam. Here is one of the examples of a question where a division strategy could be useful. As usual in GRE, you will get two quantities, quantity A and quantity B. Some extra information about them. Not guaranteed, but sometimes you are given a bit of extra information about these two quantities. And you will need to figure out which of them is bigger. Before you do anything, you need to realize that the two quantities have some kind of a relationship. What is it? This a minus b whole square is the same as b minus a whole square. Quantity a is b minus a. Quantity b is b minus a whole square. Are they related? Of course, yes, they are related. If I subtract them, I might be able to simplify them in one way. If I divide them, I might be able to simplify them in a different way. The question that you have is, should I do a by b or b by a? In this particular case, when I do b by a, I can cancel something. So b by a is b minus a whole square divided by b minus a. This is b minus a into b minus a upon b minus a. If I cancel them, I got b by a is the same as b minus a. Remember, this is capital B and capital A. This is lowercase b and lowercase a. If I look at the original one, a is smaller than b, which means b is greater than a or b minus a is positive. So after division, I notice that the result I got is positive. When would a division be positive? When I am taking two quantities and dividing, what does b by a greater than or equal to 0 mean? B by a greater than 0 will tell you that either both of them are positive or both of them are negative. We already know that b minus a is positive. We are looking at b minus a, right? We already also know that this particular side is positive. As a result, we can say, hey, b by a is greater than 0. We are dealing with two positive quantities. Is this more than 1 or less than 1? Look at b minus a. When a and b are two quantities which are both less than 1, both lying between 0 and 1, your b minus a has to be less than 1. Yes, on the one hand it is more than 0, on the other hand it is less than 1. This is the crux of the division strategy. Whenever you are dividing, you will compare against 1. You will not check out for 0. In the subtraction strategy, you will compare it against 0. In the division strategy, you will always be comparing against 1. So, when I did b by a, I should not actually do with greater than 0, because greater than 0 is important but not enough for me. What I really need to worry about is, if b by a is happily greater than 1, I can say that b is greater than a as long as, if and only if, a comma b are positive. If things are negative, do not use the division method. Just write down here, only for positive quantities. When things are negative, the method can get very complicated. It's very easy for you to lose track. So use the division method when you know that the quantities given to you are positive quantities. If b by a is greater than 1, it means b is greater than a. You will happily mark option 2. Similarly, if b by a is less than 1, it means b is less than a. You will mark option 1. If b by a is equal to 1, that's also good news for me. We'll say b is equal to a and we'll go ahead and mark option 3. If it is sometimes more than 1 and sometimes less than 1, that's also good enough for us, because that will mean that the answer cannot be determined. We'll go ahead and mark that and get the answers. So in this particular case, we got b minus a as a capital B by capital A as b minus a, which is less than 1. So I can say b by a is less than 1, which means that b is less than a. Remember the condition again. This method is useful only for positive quantities. The moment a quantity is negative, you cannot use this method. So b is less than a or a is more than b. You can mark the answer as option 1. The quantity a is greater than quantity b. What is the crux? We are getting it using division. When can you divide? When the quantities are positive. If they are negative, division can get extremely complicated. I would strongly recommend you not to attempt it. Let's now take up one more question, which is again based on the division strategy. So here is a question where you have two quantities A and B. 0 less than A less than B is the first condition, which means that both of them are positive. First condition. Of course, A is a smaller quantity, B is a larger quantity within capital A and capital B. It's also mentioned for whatever reason that B is not equal to A plus 1. I don't know how to use this, but that information is available. The first thing that you need to realize is B minus A is positive. How do I know? Because B is greater than A, B minus A is positive. So I am looking at comparing B minus A whole square with B minus A whole cube. Obviously, you can divide because things are positive. Had they not been positive, you would have been jittery about dividing. So capital B by capital A would be B minus A whole cube divided by B minus A whole square, which is equal to B minus A. Is this positive or negative? You would say, sir, this is positive, brilliant. But wait, we are using the division strategy. It means I need to compare against 1. A lot of people get this wrong here. You should always compare against 1 when you have divided. So yes, while I'm able to say that B by A is greater than 0, but that is not enough. Is it more than 1 or is it less than 1? B minus A, I have no clue. What if B is equal to say 1.25 and A is equal to 1.2? Even these two numbers satisfy the conditions given to us. In which case, yes, B minus A is positive, but B minus A here would be 0.05. Obviously, this is less than 1. However, instead of 1.25, it could be 2.25, it could be 10.25 also. So there's also a possibility that B by A to be, so B minus A to be greater than 1. So if it is less than 1 sometimes and greater than 1 sometimes, you need to say the relationship cannot be determined. Why did I say it's sometimes greater than 1, sometimes less than 1? Here I had used one example. Example 1, where B equal to 1.25, A equal to 1.2. I could satisfy all the conditions given in the question and found that B minus A in this first case is less than 1. If I take say B equal to 7 for the all that you care and A equal to 1, you would get B minus A equal to 6, which is greater than 1. So I have an example where it is less than 1. I also have an example where it is greater than 1. That is when you can confidently mark the answer as the relationship cannot be determined. This concludes the second method that we have for quantitative comparison.